Lena, you're muted.
We can't hear you.
Okay.
There we go.
Try again. Can you see the screen though?
We can.
Good. Thank you, Irene, for the introduction. We will now be presenting the report, The Decline of Cod in the Baltic Sea, a review of biology, fisheries and management, including recommendations for cod recovery. We'll start by telling you who we are as authors, and then about the study, including the aim and the method used, and then our findings in the study, which include a description of the current status of the Baltic cod, the biological stressors affecting it, the fisheries management related stressors, the road to recovery, and the recommended actions. My name is Lina Birgersson. I've done a PhD in biology focused on environmental chemicals in fish. And my co-author, Sara Söderström, has a PhD in environmental science with a focus on marine environmental governance and ecosystem-based management in the Baltic Sea. And FishSec is an independent non-profit organization dedicated to the protection and restoration of marine ecosystem services with a focus on fisheries. This project was funded by Postkodstiftelsen as part of the project grant Return of the Cod. And it's also funded by the Swedish Agency for Marine and Water Management. The aim of the study was to summarize current scientific knowledge when it comes to the Baltic cod, including the state of the cod, the factors responsible for the current state, and possible measures that scientific studies suggest that could be taken. And the method was based on a literature review of academic papers and reports, again focused on the status of the Baltic cod, the changes that have happened to the stocks, the factors that are assumed to contribute to these changes, and suggested measures that may counteract the issues. We didn't analyze novel data, but rather summarized information already found in published scientific literature and reports. And this is to give you an overview of the workflow of the literature study. So we started out by identifying possible papers using a systematic search of peer-reviewed material with the Scopus literature database and predefined set criteria. We found 869 papers there, published over a period of 20 years up until February 2021. And this included scientific papers, reviews, short communications, books, and conference abstracts, the latter being non-peer-reviewed and considered grey literature. On top of that, we added recent reports and papers published after February 2021 after scanning those for relevance. And these reports also are considered grade literature. And then the papers included were selected or sorted into relevancy categories and excluded if they focused on a different species than the cod, if they were outside of the geographic scope, meaning not in the Baltic Sea, if they focused on cod as a food product only, those were mainly food chemistry papers, or if they were inaccessible to us due to language barriers or because the full paper was not retrievable. And one limitation of the study is that only materials written in Swedish or English were included in the review. So part one will describe the current state of the Baltic cod. But first of all, I'd like to tell you about the Baltic Sea a bit more. So the Baltic Sea is a challenging environment for an organism to live in. It's considered one of the most contaminated areas worldwide, and apart from pollution, it also suffers from eutrophication and climate change. Apart from that, there's also natural hydrological variation in different conditions, including temperature. There's a temperature gradient from north to south. There's a salinity gradient, and there are varying levels of oxygen throughout the water. The salinity in particular means that this is a difficult environment to adapt to for both freshwater and marine species. But the cod is one of the fishes that have been able to do this, and they've been a vital part of the Baltic Sea ecosystem, where they were considered a top predator. So there are two genetically distinct stocks of Baltic cod. the Eastern and the Western Baltic cod, abbreviated EBC and WBC throughout the report and this presentation. The eastern stock is found east of the island Bornholm, and the western stock is found west of Bornholm. So there is some geographic overlap there, but apart from that, they are distinct both geographically and genetically. They are able to reproduce in the low salinity of the Baltic Sea. Particularly the eastern stock is adapted to this and able to do so at much lower salinity than their neighbors outside of the Baltic Sea. The two stocks have separate spawning times and also separate spawning locations, where historically there's been three main spawning sites for the eastern stock: the Gdansk Deep, Gotland Basin, and Bornholm Basin. And the latter one is the only one that's still in use in a meaningful way. So 2 out of 3 of these have been lost over time. And the western stock is spawning further west, including in the Arkona Basin. So the current status for both of these populations are poor. Both stocks are in poor shape. You can see the graphs on the right here illustrating the spawning stock biomass for the eastern stock on the top and the western on the bottom. And after an increase during the 80s for the eastern stock here, you can see a sharp decline, and the western stock was not following very far behind after in the same trajectory. So both of them have declined, and this decline has coincided with a period of high fishing pressure and also reproductive failure, including the loss of those 2 out of 3 spawning sites for the eastern stock. So another thing that's worth noting is that age determination can be difficult in the Baltic cod, and that's something that many papers focus on. Because age determination is difficult, growth estimations are also difficult to make, and this affects the data used for stock assessments. So over the last decades, there have been several big changes to the Baltic cod. First of all, the reproduction and productivity have decreased, and this is a list summarizing what we found in the scientific literature. The distribution range became more limited. Both of these can be attributed to the loss of spawning sites. But then we have a few other changes as well. For example, the condition has gone down, and condition, or weight at length factor, gives a general indication of a fish's well-being. So the fish are now skinnier, and their health has also decreased. The range of sizes has become smaller, so they are more similar in size and therefore compete probably over the same food. And in a normal stock, there would be a range of different sizes from very small to very large individuals with different prey species and different roles. And these very large individuals are important both as top predators and also for reproduction, as they are usually capable of producing more eggs, for example. And those large individuals are now almost gone completely. Apart from that, the fish are also becoming sexually mature at lower sizes. So if you can see the image or illustration on the right-hand side, we have an example of the size of at sexual maturity during the 1990s, which was around 40 centimeters, compared to what it is today, which is closer to 20. So that's a very big difference. And that might indicate that the cod are adapting to being smaller in size. And apart from these points, there's also a higher number of parasite-infested cod in the Baltic Sea. So how did it come to this? Well, according to the literature study we've made, there's a number of factors that could contribute, but there's no scientific consensus when it comes to what the main driver is, and the situation is complex and seems to be a combination of many factors. So we have tried to illustrate some of the main ones mentioned in scientific literature in this illustration, which is also found in the report. And this includes fisheries-related factors in the top left and non-fisheries related factors, including climate change, pollution, access to food, habitat destruction, eutrophication and hypoxia, and predation and parasites. Here the list is again a bit more specific. So we've split them into non-fisheries related factors and fisheries related factors. eutrophication and lack of oxygen, lack of food, climate change, seal predation, seal parasites, and other factors, including cormorants, thiamine deficiency, chemical pollution, and chemical warfare agents are all topics we'll cover in the presentation today. And then Sarah later on will cover the fisheries-related factors. So I'll first of all move on with a description of the non-fisheries related ones, including eutrophication and hypoxia. So eutrophication is a process where excess amounts of nutrients are put into a water body, and this is mainly nitrogen and phosphorus, which in turn leads to an increase in organic matter in the water. This often leads to a water quality change, and a common consequence is a depletion or reduction of the amount of oxygen in the water as this excess organic matter is being decomposed. The Baltic Sea started out relatively nutrient poor, but then became more nutrient rich as a result of human activities and emissions during the 1900s. And it now has so-called dead zones, which are areas completely depleted of oxygen. And the oxygen depletion can be connected to a loss of spawning sites, and of course also a loss in productivity and reproduction as a result of the loss of spawning sites. Apart from that, the hypoxia or low oxygen conditions can also be linked to a reduction in benthic food availability. And this can lead in turn to a reduced growth in the younger cod that use that as one of their food sources. Some studies also show direct effect of the low oxygen conditions on growth and body condition of the cod. But a new study has shown that hypoxia is unlikely to be the main driver of the poor condition of cod in the Bornholm Basin area, as the hydrographic conditions in this area has stayed the same over the last 60 years, roughly. But the decline of the cod has still been going on. So other factors than hypoxia are likely to be the drivers there. Lack of food is another factor. The diet of the cod changes with their age and their size, but for adult cod, the sprat and herring are one of the important food sources. And a lower food availability can naturally affect the growth, but also reproductive success, according to studies. Over the past decades, so from the 90s and 2000s, there's been a reduction of the spatial overlap, so geographic overlap between the cod and their prey species, as sprat and herring populations have been moving further northeast, whereas the distribution range of the cod has been narrowed down and moving more to the southwest, or more narrowed down at least towards the southwest. So with this reduced overlap, there's a reduction of food availability. However, some studies have shown that the intake has not changed or not significantly changed over the past decades, and suggest that quality rather than quantity of the food might be one of the contributing factors to the poor condition. So climate change, of course, is not a specific problem to the Baltic Sea. It's a global problem, but changes linked to the climate change have been shown in experimental studies to be linked to physiological stress in cod. And this includes reduced salinity, which is also seen in the field. So oxygen levels and reduced salinity have already been linked to a reduced reproduction. Increased ocean acidification, which leads to a lower pH, is assumed to be especially bad for the younger life stages, and this is based on experimental studies, and then includes eggs and larvae of the cod. And increased temperature is also expected to have a negative impact, especially since the Baltic Sea is relatively shallow and quickly to warm up. When it comes to seals, our knowledge about their diet is still quite limited, but the amount of cod seems to vary depending on the location, from a few percent to a larger proportion of the Stagan content, a third even. And studies have shown that predation from seals have a relatively low impact on the cod condition and the cod stock compared to other factors, including fishing and salinity and oxygen. But locally, the seals could affect cod mortality. So based on the literature study, we can't say that the decline can be explained by seal predation alone, but recovery of the cod stock, which is already depleted, may be affected negatively by any stressor. Seal parasites are also, of course, linked to seal presence in the Baltic Sea. So these are nematodes which can be found in either the liver tissue or muscle tissue of the cod, and they use seals as their final hosts. However, the effects of these nematodes seem to be smaller or insignificant when the cod has a high food availability. So it's possible that weakened fish that are lacking food may be more susceptible to parasite infestation rather than the parasites causing them to have a low condition in the first place. So there's still more research to be done here. When it comes to cormorants, they have been shown to have a local impact on some fish species, but that study did not see any effects on cod. In the Blekinge archipelago, which is in the southern Sweden area, cod was found to be a common prey for cormorants, but further studies are needed in order to assess the impact of cormorants on the cod stock. Another factor mentioned in a recent study is thiamine or vitamin B deficiency, because a study found that the Eastern Baltic cod were thiamine deficient, and this could be one of the explanations for the decline in their condition, as well as reproduction and growth. Thiamine deficiency is a well-studied topic in some other species, including salmon in the Baltic Sea, but studies in Baltic cod are limited to date, and more research is needed. Chemical pollution also, so I mentioned previously that the Baltic Sea is one of the most polluted sea areas in the world, and traditional pollutants, and that includes pesticides, PCBs, heavy metals, have been regularly monitored and seen as a problem for some time. However, the tissues in cod, apart from the liver, are relatively low in fat compared to, for example, a salmon or a herring, and therefore will not accumulate the fat-soluble compounds as much, even though they are top predators. So more studies need to be done with both traditional and emerging contaminants. And lastly, we have the chemical warfare agents, and these have been dumped after World War II and can still be found in deeper areas of the Baltic Sea, including in the Bornholm Basin, in the Gotland Basin, and in the Little Belt. And the Bornholm Basin particularly is a problem, as that's a spawning ground for the Baltic cod. And one recent study found that 14% of the cod from this area contained phenylarsenic chemicals, which were related to chemical warfare agents in their muscle tissue. So it's recommended that both pollutants and chemicals related to chemical warfare agents are continued to be monitored, and toxicity testing should also be continued to be done. With that, I'll leave the word to Sara for some fisheries related factors.
Thank you, Lina. I'm trying to find my video. Okay, so everyone, I will now continue to talk about the fisheries related factors. And it was one that stood out in the scientific literature review, and this was the bottom trawling. So I will speak a bit about this now, because bottom trawling disturbs the non-target species and the seabed itself, making it flatter and less complex. It decreases diversity, lower abundance of benthic invertebrates, and also affect food availability for fish and abundance of fish. Furthermore, it resuspends sediment into the water, causing turbidity, and this have a negative impact on eggs and larvae. So one measure suggested in the literature for the recovery of the Eastern Baltic cod would be to protect nursery habitats in specific areas from trawling. And one good example here is the cod in the Öresund area, where bottom trawling has been prohibited since the 1930s And in this area, the cod is actually in quite a good shape. So I will continue with overfishing as one of the stressors related to fisheries. And here we can see the TACs, the total allowable catches. This is basically the same graphs that Lina showed with the SSB, but this is instead catches. And you can see that there's a steep decline in the Eastern Baltic cod and also a decline in the Western Baltic cod, steady since the 1990s. And according to the Common Fisheries Policy, the TAC should be in line with maximum sustainable yield at 2020, the latest, and this ambition has not been met. Furthermore, the EBC regarding the Eastern Baltic cod, the TACs has exceeded scientific advice since 2013. And because of this, it was a ban on targeted Eastern Baltic cod fishing from the summer of 2019, and this still is valid. And the EBC stock is currently at its lowest point ever. And none of the Baltic stocks are currently reproducing properly. And this is also a graph. This is data from ICES, and here you can see a quite large discrepancy between the advice, that is sustainable fishing according to science. This is the light blue graph, and then you have the TACs, the agreed fishing quotas in the dotted green, and also the actual catches in dark blue or dark purple. And as you can see, it's quite a difference between the scientific advice for sustainable fishing and catches. And according to the literature survey, this is one of the major causes for the decline of the Baltic cod. But there's actually something that can be done that is within the legal room of the CFP, and this is Article 17. And this is basically how member states are allocated the TACs domestically. And this allocation should be based on transparency and objectivity, according to Article 17. So the member states should provide incentives for selective gear or low impact techniques, and provide for optional use of economic, social, and environmental criteria. However, very few member states actually do this. Instead, the TACs domestically are distributed due to historical catches. But properly implemented, Article 17 could be used to promote low impact fisheries. And then I will speak about bycatch and discards. These are the last of the fisheries related factors. I will take them together. And I will speak a bit about the landing obligation. It was introduced in 2015, and it states that basically all catches must be landed. Because discards, it's a waste of resources and a practice of unsustainable fishing. So previously undersized and unwanted catches were discarded. However, after the introduction of the landing obligation, the practice of discards has not stopped. This is data from ICES in 2019. Discards were estimated to account for about 14% of the total catch weight of Eastern Baltic cod. And I must underline here that the Baltic cod is no longer a target species. It is caught as bycatch. So how do you avoid bycatch then? Well, traditionally, a selective gear lets the young, small individuals escape, keeping the large one because those you can sell, the small ones escape, they grow, and you can catch them a few years later. However, today, the survival of the large cod is important. As Lina said, there's basically no large cods left. So we need to rethink the purpose of selective gears and instead save the large cod. But again, as I said, there's no targeted fishing for cod allowed in the Baltic Sea. So where is the cod then caught? Well, it's in the flatfish fishery because cod is a bycatch species. So now the focus for selective gears are targeting flatfish gear to let the cod escape. And there's the use of new cod and designs in commercial fisheries could be a more sustainable option here. And then how do you actually control that things are being done as they should? Well, there are several methods for monitoring, including observers on board, surveillance with patrol vessels, self-sampling, vessel-transmitted information, and electronic monitoring. And one thing stands out in our literature survey, and this is the use of EM or REM. That means remote electronic monitoring. And this is seen as a vital part in at-sea monitoring. Basically, because it's time and cost effective. It ensures good fishing management and better protection of marine resources and ecosystem. It's actually described as a game changer for transparency and accountability. It provides reliable data and overcome difficulties with observer reports. And then I will shortly speak about the legal outlook. And it's a bit complicated, but there are surely very clear connections between fisheries and environmental law. And the most coherent framework, though, is the ecosystem-based management, EBM, or ecosystem-based fisheries management, EBFM. Also, the precautionary approach is highlighted. For example, we can see in the Common Fisheries Policy, makes clear links to the Marine Strategy Framework Directive and the Good Environmental Status and so on. So all within these different frameworks, they are connected to each other. And I will shortly speak then about ecosystem-based management or ecosystem-based fisheries management, because these are legal requirements in the CFP, the Baltic Map, the Marine Strategy Framework Directive, and in the CFP, it is phrased ecosystem-based approach to fisheries management, but these different wordings can change. So the basics of ecosystem-based fisheries management then, well, it's actually a shift from single species management to multi-species management. And it needs to do ecosystem connections and have a holistic approach to consider ecosystem functioning and processes as well as species. It also needs to consider that the outtake of biomass should not exceed the productivity of the ecosystem, and also consider the long-term socioeconomic benefit without compromising the ecosystem. And also here, the precautionary principle is essential, where greater uncertainty should result in more precautionary fisheries. And I will continue to speak a bit about the precautionary approach or principle, because this is again part of EBM, EBFM, CFP, Baltic Map, and other treaties like the Treaty of the European Union. It's old, very old within environmental science and also in other fields this is used. And nowadays the precautionary principles is institutionalized within environmental management. And you can see a very practical example. This is ICES using a precautionary approach in their stock assessment. And this is a practical adaptation of PA in the advice setting. But this specific use of the PA should not be confused with the precautionary approach within environmental management. So I will now also speak shortly about the Baltic Map. This is the multi-annual management plan for cod, herring, and sprat in the Baltic Sea, and it was introduced in 2017. This is an attempt at multi-species management. I quote, "Since strong biological interactions exist between the cod and pelagic stocks, the size of the cod stock can affect that of herring and sprat stocks and vice versa. So a few years later, the European Commission made a evaluation of the Baltic map, and they concluded that the Baltic map had reduced fishing pressure. However, the Baltic map has received massive critique, basically because it introduced the MSY ranges, and that this has instead created a higher fishing pressure. And when you look at the fish stocks today, both cod stocks are at its lowest SSB ever, and herring in Central Baltic is also in a dire condition. And speaking about the environment, as Lina had gone through all of these different environmental factors, I need to speak very shortly about HELCOM, the Helsinki Convention with the Helsinki Commission, the first regional seas convention ever made with the aim to protect the Baltic Sea marine environment, with all Baltic countries and the European Union as signatories. And the HELCOM has the Baltic Sea Action Plan. It was updated last year. It covers biodiversity, eutrophication, hazardous substances, and sea-based activities, although not so much in fishing. However, these are experts on the environment. So, lastly, I will now discuss our recommendations. These are, of course, based on what we found in the literature review. And it's implement an ecosystem-based approach to fisheries management, make fisheries sustainable, and improve environmental protection. I will go through these and then I'm finished. So first of all, implement multi-species management in demersal fisheries. And this is clear. A proper multi-species management must be implemented. A shift from single species advice to multi-species advice. And remember, EBFM is a legal requirement in the CFP. And then number 2, add a sufficient precautionary buffer to the fishing quotas and catch limits. As have been shown, current tax setting has not stopped the decline of the cod. A large precautionary buffer must be set to give cod space to recover. And lastly, set industrial fisheries limits based on the precautionary approach and EBFM. The cod is starving. It's vital to consider sprat and herring as food for cod when discussing the fishing opportunities. That is, use a precautionary buffer in the tax setting process for forage fish. Number 2, make fisheries sustainable. First of all, prioritize low impact fishing. Implement Article 17 of the CFP and give low impact fishing priority access to fishing opportunities. Second, make remote electronic monitoring mandatory in fisheries. REM is a cost and time effective way to ensure compliance with fishing regulations at sea. Trials have shown huge benefits with this system. And lastly, mandatory selectivity measures to reduce bycatch. As I have told you twice, cod is no longer a target species. Selective gear that releases large cod in flatfish fishery is necessary and must be mandatory on all vessels where cod bycatch is a risk. And last slide, improve environmental protection. First of all, implement the HELCOM Baltic Sea Action Plan. Environmental efforts must be targeted jointly in all Baltic countries, and HELCOM provides a perfect platform for environmental protections. It has been there since the 70s. And secondly, actively work to restore damaged ecosystem and minimize bottom trawling. The practice of bottom trawling is undisputedly harmful and should be minimized. Also, the restoration of cod habitat is essential. And lastly, connect fisheries and environment in legislation, policy, and implementation. Full integration of fisheries and environmental policies is needed. The legal framework is already there. Now we must start using it. Thank you for